All right. I'll be back.
Can you leave out 5 minutes?
Sure.
Okay.
I didn't even touch the brakes here.
You're so cute. Oh my God.
I'm going to go ahead and erase problem number 9. Number 10 is from the very last section that we covered, I think 8.6. It's a quadratic inequality. So the first thing we have to do is find critical points, because we have to split up our number line to check regions to see where our quadratic inequality is true. So how do I find the critical points? I will put it in standard form eventually. The first thing we want to do is replace the inequality symbol with equals, because our critical values are where our quadratic is equal to 0. Then I would put it in standard form. So that means I would need to subtract the 6. Correct. So I want to see equal factor. I need to go 3 times -6. And that gives me There are any two values that give me negative 18 that will add up to negative 7.
Negative 9 plus 2.
Negative 9 and positive 2. That'll add up to a negative 7. So let's factor it. 3x squared minus 9x plus 2x minus 6 equals 0. What can I factor out of that first grouping?
3x.
3x. That leaves me with?
X minus 3.
Correct. What can I factor out of that second grouping?
2.
And that leaves me with x minus 3. Always a good thing, they have to match. So x minus 3 is one of my factors. And 3x plus 2 is my other factor. Remember, this is still set equal to 0. So I'm going to set my factors equal to 0. X minus 3 equals 0. And 3x plus 2 equals 0. So x equals 3 for this one. Subtract 2. So x ends up being what for my second critical point?
Negative 2.
Negative 2/3.
Negative 2/3. So those are my critical points. What I'm going to do is use those critical points and split my number line into regions where I can check whether it's true or false. So negative 2/3 on the negative side, 0's over here, 3's a little bit further down the line. We want to check each region. So we want to pick a number less than negative 2/3 to check over here to the left. So what's a number that's less?
Negative 10.
Negative 10. Anything smaller?
3 on 3 would give you negative 1.
Negative 1.
Negative 1.
Right, negative 1 is less than negative 2/3. You can plug in negative 10 if you want. I'm going to go with the smaller number. Something between negative 2/3 and 3.
Marie, 0.
0.
0, right?
Yeah.
0 is always easy to plug in.
And then 4.
And we'll test something greater than 3. And like Johnny said, we do 4. So let's plug those into our inequality. So we've got 3x squared. You can use the original. Let's plug negative 1 in there. 3 times negative 1 squared minus 7 times negative 1 less than or equal to 6. What's negative 1 squared?
1.
1. Why can't I multiply the 3 first and then square it?
Because negative 1 is in parentheses.
Well, it's order of operations. We have to do the exponents first. So make sure that you're sticking to those order of operations. Exponents come before multiplication. So 3 times 1. And then we'll move to multiplication. 3 times 1 is 3. Negative 7 times negative 1.
7.
And we're left with the statement 10 is less than or equal to 6. Is that true or false? It's false. So we're not going to be shading that region. So let's move to the second region. We're going to test 0. So if I plug 0 in for x, what will I have left on here on the left side?
0.
0. And is 0 less than or equal to 6?
Yes.
That's true. So we'll move to testing x equal to 4. 3 times 4 squared minus 7 times 4 minus 7. So 4 squared is
16.
16. 3 times 16 is
48.
minus 7 times 4.
28.
48 minus 28 is 20. So I'm left with this statement. 20 is less than or equal to 6.
Oh.
That's also false. So the only region that ends up being true is the region between negative 2/3 and 3. So let's think about this. Now, would negative 2/3 and 3 be included?
Yeah.
Yeah, and why is that?
So that's the legal.
Well, yeah, we have that. So we know there has to be closed circles, and it would be shaded in between the two. So is that an and or an or statement? That's an and. And how do we write and? X is in the middle. And we have the right number on the right side and the left number on the left. And that's the statement we're looking for.
A.
Answer choice A. Yeah, X is greater than negative 2/3 and less than 3. Any questions on that? A lot of work for a small answer.
Yeah, you didn't.
Oh, yeah, yeah.
run under.
Thank you very much. Yeah, we want to use the same symbol that we have there. Thank you for pointing that out.
Oh,
Yes.
how about the interval notation? Don't you do like the little
Well, look at our answer
parentheses?
choices. Do you see the answer choice on there? And the only thing
This
that
is
really
in
wanted
Mrs.
was
Allison's class.
yeah.
You're like, hello, hello, hello.
But what would the interval notation be if you needed that?
Deep bracket.
That would be the interval notation.
Okay,
Right.
okay, love it, yes.
But the, because it doesn't go to negative anymore. It's trapped between these two.
Oh, I know, but you said the word like,
Yeah. This is the interval notation matches.
We will be putting forms that will mean parentheses.
Yes, that's correct.
Instead of brackets would be.
It'll be parentheses. On the final, what they're going to be wanting is the inequality notation.
Oh.
They're going to be wanting the and statement or the or statement. So that's what we're going to be looking for.
That's what they're gonna.
Yes.
Oh.
What would have made that alone?
If this was flipped over, this one was greater than. And you have two critical points.
If it were an
And it was
or,
positive.
if it were an or with the shaded portion.
The shaded would be these two sections. Like when you tested it, this would have been true, and this would have been true, and this would have been false.
Oh, okay.
It would have looked like an or statement.
So wherever the true statements are is where you shaded.
Yes.
Maria.
And I think that maybe another question he's trying to ask you, Kurt, is can you tell by the inequality whether it's the and or an or?
I can tell that.
Okay, you can, not with the quadratic
Yeah,
inequality.
with quadratic inequalities, it has to, there's so many stipulations it has to follow that I would stay away from trying to recognize. Because with an absolute value, you can look at it and know, well, I know that's an and or an or.
Yeah.
It's a little bit tougher with the quadratic.
Except to plug in the numbers.
That's why you really want to go through and test the regions. Any other questions? All good questions.
Keeping you on your toes, Mr. Clark.
I
Yes.
don't want to get any taller.
How do you determine the slope of 3x minus 4y equal to 4?
Slope intercept.
Okay, put it in slope intercept form, or another way of saying it is just solve for y, right? Solve for y. So I need to move the 3x to the other side, so we're gonna have to subtract it. Once again, I'm just trying to solve for y. So how are we gonna get rid of the negative 4?
Divide.
Okay, we're gonna divide by negative 4. So y is gonna end up being 3/4 x, and it is positive, right? A
Yes.
negative divided by negative makes it positive. Minus 1, because of the 4 divided by negative 4. So the slope of this line is 3/4. But notice they're asking me to find the slope of the line that's perpendicular. That's the word in there, perpendicular. So what would I need to do?
Like that.
Change
That's right, flip it and change the sign. So it's a negative 4/3. So you have to flip it and change the sign in reference to perpendicular. All right, we gotta move on to step 2. All right, we're gonna use the point slope formula, which is y minus y sub 1 equaling the m times x minus x sub 1. All right, they gave me the point, I now have the slope, so we're just gonna plug in that information. So we're gonna have y minus my y value, which is 8,
Yes.
equaling to, what's the new slope? Negative 4/3, I have to use it. Times x minus my x value, which is 6. Alright, let me move out of the way. So I gotta get rid of the parentheses somehow, so we're gonna have to distribute.
Yes.
Okay, so we have y minus 8 equaling to a negative 4/3 x. All right, now a negative times a negative is gonna give me a positive. That's right, 24 over 3, but that'll reduce, right? That'll make it nice. What is 24 divided by 3? 8, okay, so let's keep going. Okay, now where did we get the 24 over 3? Because I saw some of y'all give me the dirty look. All right, that's right. We're just multiplying straight across, right? Straight across. So the negative 4 times the negative 6 gave me the positive 24. The 3 times the 1 gave me the 3. Okay? All right, we're trying to solve for y, so what else do I need to do? That's right, add 8. So y is going to equal to a negative 4/3 x plus 16. Plus 16. All right, which one should we be picking? If it, hopefully it's on there. A is an apple. At first I almost said D, what's the difference between A and D? That's right, so be careful. Always tell my students, y'all get number happy, you see something that looks familiar and you start picking it. Be careful.
We'll go with number 11, first off. Got it? Good?
You showed me this, it really easy.
Yes.
Gotta refresh my memory.
I'm going to show it again. That's fine. All right, the infamous flow problem, right? Upstreams, downstreams. Boat and current and all that good stuff. So we've got this boat and given us information about how long it takes to go such a distance downstream, how long it takes to go such a distance upstream. What are they asking for? What are they wanting? The speed. So is the speed a distance, a rate, or its time?
Rate.
It's a rate. Right? Rate is how fast you're traveling. So how could I solve this equation for rate?
Distance divided by time.
Right. I could divide both sides by t, correct? Yes. So r is equal to e over t. So downstream, I have two speeds to worry about, right? We've got b, we'll call that the boat speed. And C we'll call the current. So if I'm going downstream, is the current going with the speed of my boat, or is it going against the speed of my boat?
Just push it.
It's pushing it, right? It's adding to it. So downstream, my boat, my speed will be the boat speed plus the current. And that equals to the distance divided by time. So how far is it traveling downstream?
32 miles.
32? How long does it take?
4 hours.
4 hours. If I'm traveling upstream, is my current going against me or with me?
Against.
So my speed would be the boat minus the current. How far am I traveling upstream?
16 miles.
16 miles, right? And how long is it taking, how long is that trip taking?
Same amount.
Same amount.
Same amount of time, so
4.
4, right? The same amount of time it took the downstream trip to take. Well, can I reduce those fractions? Can this
Yes.
divide evenly?
84.
So B plus C equals 8. And B minus C equals what?
4.
I have a really easy elimination problem now. What cancels out?
C's. Current.
C's cancel, so B plus B is
2B.
or not 2B. 8 plus 4.
12.
So my boat speed is what?
6.
6 miles per hour. But they're asking for the speed of the current. So how can I find that?
Substitute.
Just substitute. Go back to one of the two equations. Looks like this one's pretty easy, right? So 6 plus C equals 8. So if I subtract 6, what's the speed of my current? 2 miles per hour. That's it. So what answer choice would that be?
8.
That's going to be letter choice. Okay. Anytime we have that situation where we're looking for the speed of the boat or the speed of the current, use that situation. You can just use B plus C equals the downstream case, distance over time. Upstream, B minus C equals the distance over time. You end up with a really pretty easy elimination problem to work. Any questions on that? Join it. Okay. Number 13. Which is should be very familiar.
On 13, they're asking us to find the vertex of this quadratic function. So we're going to go through and label the different parts so we can use the formula. So A is going to be 2, and B is going to be a -5. So let's start off finding x. So x is going to equal to the opposite of b, which is a +5, divided by 2 times a, which is 2. So we're going to end up with 5/4 for our x component. All right, to find the y that goes with it, basically we're just going to take that and substitute it. That's all we're going to do. So y is going to equal to 2 times 5/4 squared minus 5 times 5/4 plus 3. All right, so once again, I'm just taking my x value, plugging it in place of the x to find y, substituting that value in. I got to be careful about the order of operations, correct? So I got to go to the exponent. All right, so what about this 5/4 squared, meaning 5/4 times 5/4?
25/16.
All right, 25/16. And the 25 coming from 5 times 5, 16 coming from the 4 times 4. All right, that 2 is really 2 over 1. Y'all in agreement? So I can do some canceling. Might make it a little bit easier. If I cancel the 2 and the 16, what am I left with? An 8. And where's the 8 going to be? At the bottom, the denominator. Right, y'all okay with that? That's right. 25 over 8. Over here, remember that 5 that we're subtracting here, this product, is really over 1. And when you multiply, that's going to give us minus 25 over 4 plus 3. We could get a common denominator for all that information if you want to. That's usually how we've done it. For some of you, it might be easier to multiply to get rid of the fractions. So what would you multiply by if you wanted to get rid of the fractions? 8. So you multiply this side by 8 as well as the right-hand side. Don't have to do this right. We could get a common denominator for all 3 of them, combine them, just whatever's easier for you. So that's going to be 8y equaling to what? 25 minus what? 50, I heard somebody say it, plus 24. All right, so 8y is going to equal to, what, a -1? They'll double check me. So 25 minus 50 gives me what, a -25? Combine it with a positive 24, it's going to give me a -1. So what's y going to be? -1. All right, so let's look at our ordered pair. We have 5/4, because that's my x. What about the y value? That's right, -1. Which one should we be picking on 13? A. A is an apple. What made that one a little bit harder?
The fractions.
The fractions, you know, struggle a little bit with the fractions. But keep in mind, you could have gotten a common denominator for all of them. And you still would end up with the same thing at the end. Questions on this one? Good to go? Makes sense?
How do we develop that formula from S?
It's just using function notation. So basically it's saying whatever you get for your x is what you're putting on the inside here. So if this was in function notation, you'd be taking that number, putting it in place of x, and continuing on. Any questions on 13? 13. All right.
here, so you're 14.
Oh!
Come on, Charmaine, you want to do it? All right. Can I erase number 13? Everybody good with that one? All right. Is asking us to divide, and we have two complex numbers there, 6 plus 3i and 6 minus 2i. Why can't we just leave it the way it is? I mean, why do we have to do something to it? Imaginary. There's an imaginary number at the bottom. What does I really represent? The square root of -1. So if you took 0310, remember you couldn't have radicals in the denominator. We have to get rid of them. So that's why we have to do something to change the way it looks. So what do I have to multiply by?
Well, 6 plus 2i.
Conjugate.
Conjugate, yeah. And what the conjugate is, it's the same as the bottom, same elements,
Different sign.
but the middle sign is different. So it's not technically the opposite. The only sign you're changing is the one in the middle. And what we multiply the bottom by, we have to multiply the top by. Because it doesn't change the value from multiplying by 1. So, yeah, I heard somebody say FOIL, that's correct. We do want to FOIL the top and the bottom. So let's do that. 6 times 6,
36.
36. 6 times 2i, 3i times 6. And then 3i times 2i.
6i squared.
6i squared. Don't forget about that squared because we are multiplying 5 for 9. 6 times 6 on the bottom.
36.
6 times 2i
12i.
plus 12i, correct?
Minus 12.
Minus 2i times 6
Minus 12i.
and negative 2i times a positive 2i.
4i squared.
Y squared. Once again, don't forget to square that on. So, are there any like terms that I can put together on the top?
So allow you
Okay.
to get rid of the positive and negative.
And that I squared is really what?
Negative 1.
So I'm really multiplying times -1 here. So 6 times -1 is
Negative 6.
-6. On the bottom, I've got 36. What happens to those two middle terms? Always a good thing when my i's start disappearing. Minus 4 times I squared. Remember that I squared is -1.
Positive 4.
Right. A -4 times a -1 is positive 4. So are there any other terms I could add together in the numerator?
36 and negative 6.
Which is?
30.
Okay. So I got 30 plus 30i. On the bottom, I've got 36 plus 4, which is 40. You could reduce at this stage. What I'm going to do is I'm going to go ahead and put it in standard form and then reduce it. When you have a complex number, you want to have a plus b on it, the real part separate from the imaginary. So I'm going to write it as 30 over 40 on the bottom, plus 30 over 40i. Just taking the two elements in the numerator, putting them over the same denominator. 30 over 40 reduces to what? 3 3/4, 3/4. 30/40 once again reduces to 3/4. Top of the 9. That would be in standard form. And that would be answer choice D. Any questions on that? What happens if I'm left over with any i's in the denominator? Yeah, wrong. Yeah, AKA wrong. You want to make sure, go back and check your work, because our goal is to get rid of I in the denominator, right? So if you end up with i's in the denominator, something went wrong. So go back and check. Any other questions on that one? We're ready for 15.
Alright, so do y'all remember what we need to do first on this problem 15 when they're asking us to solve anything that has absolute value?
Get rid of 8.
Alright, at some point we do gotta get it out of the absolute value, but don't we have to isolate it first? Alright, so we've gotta add the 8. So the absolute value of 2x minus 3 is gonna equal to a positive 7. And remember, absolute value is referring to a distance. So inside here, a distance between a negative 7 and 0 would have a distance of 7. As well as the distance between a positive 7 and 0 would have a distance of 7. So we're going to take 2x minus 3, set it equal to a negative 7, or 2x minus 3 is going to equal to a positive 7. And we're going to have to solve in each case. If you're looking at this first one, we're going to add 3. So 2x is going to equal to a negative 4, and then divide by 2. So x is going to be a negative 2. But we're not finished. Remember, we have another equation that we're going to have to solve. So we're going to add 3. 2x is going to equal to a positive 10. From here, we're going to divide by 2. So x is going to be a positive 5. So we're looking at two possibilities, a negative 2 or a positive 5. So which one should we be picking? Looks like it's A again, right?
Yes.
See, we're just trying to foreshadow y'all making A's on your test.
Thank you. Very much.
Yes? Because that's the value. So you remember when we had absolute values with inequalities, either with an and or an or, basically it's two parts we're having to deal with.
Let's get the practice test and go over that. Okay.
Well, usually you say X could be, so it could be both of those numbers at the same time. When you say an and, you're saying a group of numbers that satisfies this as well as this. But don't let that confuse you. You know, notice on there they didn't write it like that. They're just putting in set notation, saying it can be a -2. Okay. Any other questions on 15? That was a good question. I was afraid y'all forgot to isolate the absolute value. Anybody want to confess? Confess, Johnny. Okay, be careful.
I stopped noticing the 3 parts.
Is that one that we would, or, you would grab and do the,
Probably they will not, because on multiple choice tests, it's really difficult to do a number line and all of that other stuff. But it's a good knowledge, especially you moving on to college algebra. But I don't foresee that on a multiple choice test.
so they'll want the answer like this? Is the wording gonna be a lot like this, you think?
I mean, it'll be a lot like it. I'm not going to say it's exact. You got to be careful because some of you don't read the whole problem. You just start working it without reading it. So be careful.
Yeah, there also is practice final exams in the math lab. So if you want to take a look at the wording, I modeled the wording very much like the exam. So ask the
You
tutors.
go in there and actually do one for practice before you take the actual test.